Ladies and gentlemen, how's everyone doing? I am back from the dead. It's been it's been a while. It's been a while since we've hopped on the stream, but new year, same old me. It's not gonna be much new around here. Actually, it is gonna be new around here. I lied. Got a couple things brewing up. A couple things I wanna get going here. But let's jump right into it. Actually, yes, of course. I forgot to load up Unity. I know, LG. I know you can't see me. I gotta change the screen. Let me load up Unity first, and then I'll switch it over to screen share. I'm in the progress of setting up a Discord server right now. I actually haven't set it up. I just need to do some testing. Make sure that I'm not doing it incorrectly. But I just need to have one of my friends go ahead and test it out for me, make sure the permissions are set up correctly. And then maybe, I don't know, I probably won't worry about mod permissions yet because community's not super big. So as long as nobody here is, as long as everyone here uses their brains, it'll be fine. But yeah, so that's in the progress right now. And also, I think I'm going to start throwing in the schedule like once a month, maybe first stream of the month or something like that. I'm going to start doing play a game of some sort. I don't know what it's going to be yet. It might be different every month. It'll kind of depend up to you guys in the community, see what you guys are more interested in. But I do have a couple ideas that are I could do. But I think I want to start doing that, just to kind of mix up the content a little bit, make sure everyone's engaged, maybe try and track some new followers as well. But all right, on that note, Unity is loaded up. So hello everyone. Hello. I'm here for real now. All right. So I don't actually remember where we left off. It has been a hot second. I'm gonna go ahead and check the website and see if I even have the most updated version uploaded. Oh, don't want that. Okay, well, that's not what I wanted. Actually, let's just go through and play this. Let's do that. We're just gonna go and play this. We'll max this. And okay. Feels very fast. There's no enemies. I don't know why there's no enemies. Interesting. This is rounds. Rounds might not work, I guess. All right, plot twist. So rounds don't work. Oh, there's no rounds does work. Yeah, okay, let's try this. Wait, let's not try this. Let's try this. Okay. I must have been testing something out. I honestly don't remember what I was testing out. Oh, these boys are fast. Holy Christmas. Okay, so some of these guys are stuck. Interesting. That is definitely a new one. How did he get through there? So that's not good at all. I do not know what happened with that. Oh, we were messing around with the movement, weren't we? That's what I was doing. That's what I was doing. It's all making sense now. Goodness gracious. Well, this is gonna be fun, isn't it? Okay, so enemy movement. Let's open this up and see where we left off. So many things. All right, so we have all these checks. Let's comment these out because we're doing this down here instead. Movement's defined somewhere, right? Okay, so what's happening here is a lot of things. What is the obstacle influence max? Where are these things getting brought up? They're all just, so it's distance to obstacle. So it all happens in this check ahead, I think, right? Yeah. So we're saying, hey, I want a box 5x5. The rotation. Throw it in that direction. And then throw it in that direction this far. which is defined up here, defined by the input in Unity. And then return true if, go through the objects, and then if one of these objects is not this script's object and it's not nothing, then get the distance to that object. So essentially what this is doing is saying the closer you are to this distance, because this is as far as it throws it, right? This is as far as it's looking for an object. So as it gets, hold on, let's, let me do one of these. Oh wait, that's not one. There we go. So this is our bro, what the heck? Oh, okay, cool. That's fine. So this is our little enemy, right? And then this is our obstacle. This is so sketchy. It's ridiculous. Okay, but anyways, this is oh, whoops. Okay. So our enemy, this is our obstacle. This is the distance it sees, right? So this is the distance it sees. Or let's say that's the distance it sees. The object is only, and that's object, we'll call that object distance, that's OD. Object distance. So we want to multiply our movement by a bigger number when O of D is close to distance, which means distance, actually I guess it should be when they're close, which means distance minus OD is about 0. And then you want to do lesser value when distance minus O of D is closer to distance. So that's it's a very, very rough sketch. But that's how we get to here, where we say, okay, we're going to multiply this by this constant times a variable number, right? This is the variance right here. And this is going to be high when these two are close together. When these two are close together, it's 0. If these two are the same, right? Or sorry. Actually, I did that wrong, didn't I? When these two are about the same, yeah, I did do that wrong. Can I erase? Oh, wait. Okay. So when these two are close together, that means that that means that the obstacle is about, it's like on the edge of the site. So we don't want to affect it as much. When the distance to the object is really small, we want to affect it a lot. Because that means it's right there, which means we have to turn harder. So when the distance to the obstacle is really low, this is going to be about 1. 1 times that is high, right? This is the max value. And then when it's, no, on the edge of the site, it's going to equal 0 divided by whatever is 0 times this is 0. Now, if it's about halfway to the edge of the site, then this is going to be 1/2 times the max. So that's good. But the issue is right, that we have to calculate so there's a couple things we have to calculate, right? We have this object. This is the target. So we want to go this way. This is 1. So 1 is target. Then this is terrible. All right, we're just going to do this. We're going to I have no clue where my mouse even is. There we go. That was crazy. Okay, so we have this vector which moves to the target. So part of us wants to move to the target, which is what this is, right? We're either moving towards the player or moving towards a point, but that's our target. But then if there's an obstacle, then we also want to move away from the obstacle, right? Now, whether that's that direction or that direction or that direction, we want to move away from the obstacle. And the real question is, how much precedence does each one have, right? So like here, let's get rid of some of these. Okay, so we have an obstacle here. It's a terrible obstacle. Okay, so at this point, you would want to move a little bit this way and a little bit this way, right? To get like here. Or whatever. If you move up, it's the same vibe. But then you're here. And at this point, you want to start moving more this way and less this way. So you start moving here. Now when you're here. But then at this point, it's even harder because you're saying, like, this is more of like a, like that. Because you're moving towards a T at all times. So it's like, that's your 1, but then this is your 2. And then you end up moving, yeah, like kind of this way. And then you're here. And then you have 1 is pushing you this way. But then 2, there's no more obstacles. Like there's a little bit of an obstacle this way, so you could go a little bit this way. But then it's also, if you do it by distance, this is still fairly close to this. So you would still want to move quite a bit of ways. And now you're going over here. You're going over here. You're way overshooting the gap. And now you've gone like this. And now you know you don't see any obstacles. So you say, okay, there's no obstacles. Move this way, right? That was bad. Move. Nope. This way completely. Okay, now you're here. But now it's like, okay, move this way, but also you're still kind of close to this. So maybe move this way. Or there's no obstacle in your way. So it's just like, it's hard to tell. You wouldn't actually see it, would you? There's something else we could do. We could make a grid and use Dijkstra's algorithm. We could just go so there's these things called pathfinding algorithms, which are essentially made to find the best in a grid or a graph situation. They're made to find the most optimal point from A to B, and they can be modified to include, exclude, I guess just to include obstacles. So obviously at first your best path is going to be like here, or even if you went like this way, same vibe. Either one of those would work. But if you have an obstacle here, all of a sudden you can't take this way anymore. You can't go there. That doesn't work. So now this is obviously your best path, right? But if this is an obstacle, it says, okay, boom, 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 boom. So it's just, I wonder if this will work. So what if this, if you include like diagonals, so if you say you can go this way and this way, that's probably the fastest way. I don't know. I'm not really sure. I mean, this would be what, like 1.4, 2.8, 4.2, as opposed to this is like 1, 2.4, 3.8, 4.8. So yeah, I think this way is faster. I think this is the fastest way. But that's not really the point. The point is, yeah, so doing this is a lot more complicated if you deal with diagonals, because going diagonal isn't the same as going straight. Like going one right and one up, like one over and then one up or whatever, is not the same as going diagonal. That's just like math. This is 1 and this is 1 and this is 1.4. That's how angles work. So you have to account for all that in your algorithm. But I need like the big size. Wait, can I just... Oh, whoops. No, I want to... Okay, that was very complicated for no apparent reason. All right, so that's pretty complicated. I could do it. The reason I didn't do it is mostly because it's a lot of computing power. It's a lot of computing power. It's a lot of setup. It's a lot of management. And I thought this way would just be better. And this movement is called Boyd movement, which is what this is called, where you have like a flock of things, and there's actually 4 different. Every time they move, there's 4 different considerations. You have to consider others, obstacles, the target, and I don't know what the 4th one is. Oh man. I think that might be it. Oh, no. So you have to avoid. No. You actually want to go with others, but you also want to avoid others. Like you want to avoid collisions with others. I know that's terrible handwriting, but terrible mouse writing, I should say. But yeah, so when you have a bunch of these dudes, you want them to move together, but also you don't want them to hit each other, so they kind of balance out there. And then if they run into obstacles, for example, then you want them to go around obstacles, all while getting to the target. So that's how Boyds work. Fun fact of the day. So I have a couple different options. I can really try and make this Boyd movement work. I can scrap it. I'm just trying to think of the best way to make. I'm trying to think of the best way to make the Boyd movement work, because that's what I think I'd prefer to do. So Boyd movement, right? You need okay, so what if I actually want it to be this way. So we have our thing, right? Obstacle. Okay, so first and the target. So first thing I should do is like look at it shouldn't look at the target. It shouldn't rotate at all. It should determine vector toward the target. Okay. So that's this, right? Then actually let me want to make this here. I want to make this a little further away. There, now we have some room to play with. So you want to do that. And then check for an obstacle in that path. Okay, then if there is an obstacle, check each direction clockwise for a path without obstacles. Add to the movement vector a original movement vector. So you want to add to the original movement vector the obstacle avoidance vector multiplied by a strength based off of how close the obstacle is. Right? Right. This makes sense. Then do I need to do anything else? I mean, I would just normalize this, right? So that way it's out of 1. Multiply by speed and set as a velocity. Okay, so let's try and follow this, right? Okay, so let's try and follow this. So 1, that's towards the target. 2, check for an obstacle in this path, so that's no. Okay, so then we skip 3 and 4. So then we just normalize this, and then so now we're here. So again, do this, and we'll see there is. So then we're checking clockwise. We find one here. So let's say this is pretty shallow, right? So then we go here. Okay, see now this is where it's like, okay, this is where angles start to come into play. Because let's say this is 1. Distance to the obstacle, O, is 1, right? how far do we want to turn? How far do we want to turn? I feel as though we'd want to go about halfway and down. Because even if the obstacle ends right here, that's not a significant space, right? Because if you go halfway, that means that this is also 1. And that's a half. And that's square root of 3. Angles, baby. Okay. Which means that we would want, but you can't go halfway, can you? No, that's the problem. That's the problem. Is unless you because I feel like this is a big problem. Even if I'm trying to linearize my thoughts before I just start like rambling. But theoretically, if we went like we don't really have an algorithm to decide what the movement is. But if we're saying like movement, how did I even get to that? I don't know how I got to that. Okay. So we're saying movement equals, right, like the target vector. And then we're going to add, that's plus equals, obviously. And then we add the what would we be adding? Oh, we'd want to add the obstacle vector, right? Let's call this avoidance. Right. Like, you're always going to be hitting. No matter how far you go, you're always going to be hitting the obstacle, right? Because then m just equals t plus a. And if my vector math serves me correctly, if you're here, you have an obstacle here. If this is t, even if a is, actually let's redo that. I want to make this obstacle really close, because then t is going to be short. And even if your avoidance vector is all the way down here, you're still going to be moving here. Which I guess is fine, right? Until your obstacle is really long too. That's all the room I have. I don't know why I can't like black paint bucket unless I do this. I find it very strange. So the issue that's the issue. is that you have something like, if you have a circumstance like that, where you just have this huge thing, and like, let's be real, to do a check every single time if you're going there or there, in my opinion, it's not worth doing. Because at what point do you stop? Because if you're right here, you're like, okay, let's check there. Okay, let's check there. Okay, let's check there. Okay, let's check there. Okay, oh, we found one. But let's check here just in case. And it just... If he goes around here instead of taking the short path, it's not the end of the world. I don't think that's bad gameplay. I don't think that's a bad thing. I think that's just life. But anyways, my point was, yeah, like this is our example. So this is T. Even if A is huge in comparison to T, adding them gets you right here. And now he's pressing up against it. And in reality, I'd rather have it go like here. Or no, I'd rather have it go here. And you say, oh, well, like, I'd rather have it go here. And you're like, okay, well, why? Because following that same logic, right? It's going to do the same thing the second time because it's going to be here, here, and it's going to be even longer, right? And so then you're going to go, and you're going to say, all right, yeah, but you just flew past that. Yeah, but in reality, this distance might seem big at this scale. I keep going too big or too, that's fine. It might seem big at this scale, but this is minuscule. This distance is definitely noticeable, but you're talking like maybe that distance in the actual game. It's not gonna matter, you know? So I think the balance is finding okay, but I don't think I want to do this. I think Guy Step 4 is going to be a little bit different. So if it's right next to us, like how far do I want to move? Comparatively. Because this is all velocity. I'm not actually moving, right? Like, there's no magnitude to this at all. It's going to be normalized to 1 anyways, right? So if we're here, you have an obstacle there. And your T is going to be like that. But to max out, well, how far is the target, right? How far is that? I'm trying to think. So determine the vector towards a target. So checking for an obstacle in the path is going to be casting in the target direction. for a defined distance, right? That's really what I'm doing. And this is what that is. That's that defined distance. Because this is the target direction, and then this here is the defined distance. But when we have an obstacle that's really close, if it's right next to me, we want to make this essentially 0, right? Like we want 1 to be, I mean, you're talking like, yeah, like 0.1. And then 2 is going to be like negative 2t or something, right? Because then you're getting a vector like that and like that. But make sure no, we don't want it to be 1. We would want, I lied. The fact that you can't see the eraser, with this is very, very cruel. Okay. You want this to be, if D is the distance between like these two, you want it to be 1/2 D. Because then this is D. That's the obstacle. And then we're moving like this. I don't know if that works. I don't really know if that's... Should we base it all off that distance? If we did half D... half D... I guess we could even write it like this, couldn't we, if we were smart. Half D by D, that's a 60-degree angle. If you base them both off of the distance, oh, whoops. If you base them both off the distance, though, it's always going to be... It's always going to move at a 60-degree angle. No matter if it's... Like, that's not going to make a difference if it's here. And that's D. It's going to go here. Right? You know what I mean? That'll be D. Or if it's here. Oh, no, you don't want to do that because then it's a 60-degree angle. You're talking like that. And you're like, okay, no, we don't. You don't want to do that. No, we definitely want it to be. We want this to, I think, be a constant. Because if this is T, then that's the edge, you know, we're moving slightly out of the way. Not a ton, but slightly. But here, you're moving this way and then this way. Because then, like, if this is T. Okay. So I like that. Just try half D by T for now. So we're going to check for an obstacle. And then we're going to figure out what direction is clear. And then 4 is going to be... we should multiply the movement vector by the distance away from the object by the current distance from the object. Then, I know. This numbering is messed up. That's bad though. And then we'll just change this to 6 and 7. Okay. And then add a vector to the movement let's say calc obstacle of no. Add to the movement vector. A new vector in the direction of let's call this S. Direction of the free area with magnitude S. And at first, the first thing I'm considering is like, oh, half. Oh, wait. So our initial movement, determine vector towards a target. Then we should normalize it, right? Okay, so we want to determine the vector towards a target, then normalize it. If there is an obstacle in that path, or check for an obstacle in the path, and then if there is an obstacle in the path, oh wait. So if there is an obstacle, then you want to check each direction clockwise for a path without obstacles. Multiply the movement vector by the current distance from the object. Half the current distance from the object. All right, let's see if this works. I have no clue if this is gonna work, guys. This is quite an ordeal, I will say. Quite an ordeal. Okay. So let's go back in here. I'm gonna grab this, move it over here so I can see the steps. And then I'm just gonna add them as comments in here. So first off, and then norm. Check if an obstacle is found. Check each direction clockwise for a path with no obstacle. Then multiply the current movement vector by half the current distance from the obstacle. Then calc new, actually we can just say like create new vector with direction of free space and magnitude of the seeing distance, and add to movement vector. Normalize new movement vector. Then set or multiply movement by speed and set as velocity. Okay, so first thing, determine the vector towards the target. We do that by doing this. So if the target is not null and the distance from this to the target is less than the pursuit range, then the movement is the target position minus buffer distance minus this vector, which is a vector between the target and the current position, accounting for the buffer. And then point movement gets the current point, and if it's within the margin, it switches to the next. If it's so it gets the current point, and if you're currently close enough, then it'll switch the current point. By going to a random new point. Switch to a random new point. Okay, then the movement is the current point minus the transform position. Okay. So then here, I'm just going to do movement equals movement normalized. Whoa. Okay. So now we've normalized the movement vector. Now we're going to check for an obstacle in that path. Yeah, no, do the seeing distance. So I'm going to do if check ahead movement And do this. Because check ahead movement will... That's a direction, yeah. So it's going to cast a box from this position. That's the size of the box. That's rotation of the box. In that direction, so towards movement for the circle cast distance. Yep. So. Okay. So, check each direction clockwise for a path with no obstacle. So how are we going to do this? We would want to... It's normalized. Don't we just add 1? I guess what's... Yeah, isn't 90 degrees just 1, 1? Wouldn't we just add whatever that is to it? Why does this only work when you do that? Okay, that's so weird. Okay. I'm just goofing off now. Oh, that's so much better. Okay, so... Oh yeah, give me the line tool. Give me the line tool. Still can't, bro. All right, I have to redeem myself. That was horrendous. Is there just no such thing as a straight line, or like am I? Oh my gosh, that was ridiculous. Okay, so this is, you know, the axes. Let's see, you got a little boy here, and let's say this is your movement vector, right? How do you move 90 degrees? Well, I mean, this would be if I could. That's like close-ish, but you get the idea. I mean, this is 5'3". You're talking. This is. All right, it's obviously not all the same. Also, that is just major. This is so not mathematically good. Because that would be taller because it's still 1. I mean, if you're here, that's 1, 1, right? And here is -1, 1. So even here, it doesn't work, right? And that's 1, 0. And this is 0, 1. That's 90 degrees. But you can't just subtract 1, add 1 for all of it. I mean... Man, I don't know why I thought this was gonna be. I don't know why I thought this was gonna be easy. Let me see. Let me look at the documentation just in case there's anything there. Perfect. Returns a 2D vector perpendicular to this 2D vector. The result is always rotated 90 degrees in counterclockwise direction. In a counterclockwise direction for 2D coordinate system where the positive y-axis goes up. Okay, that's not me. Oh my gosh, who's buzzing my line? It's still not for me. Okay. Always rotated 90 degrees in a counterclockwise direction for a 2D coordinate system where positive y-axis goes up. So let me try a couple things real quick. So let's do debug.log vector2 dot perpendicular new vector2 1 0, and then let's copy this again, and this time do -1 1. Okay, let's save this, go here, and then just hit play. Let's see what happens. Let's see what happens. Well, let me. Okay. So we get 0 1. Yep, so it's counterclockwise. And then -1. 1 gets us -1, -1. Okay, so that works. All right, so here's what we're going to do. That makes our job really, really easy. Really, really, really easy. And we're going to change this to counterclockwise. Okay, so that's false. Wait, no, if that's true, that means an obstacle's been found, right? Do vector 2 m equals movement, right? Then we're gonna do while check ahead m and then we're just gonna do loop while the current vector has an obstacle. Let's say hits an obstacle. And actually, we won't do that. We'll do vector 2 dot perpendicular movement. And then m equals vector 2 dot perpendicular. Boom. So loop while the current vector hits an obstacle and isn't the original movement vector. So and m does not equal movement. I also want to do debug let's actually I want to move this out, actually. All right, let's do private void. Actually, no, private vector 2. Find open direction. Take in vector 2 direction. Do that. Okay. This, yeah, return vector 2 dot perpendicular direction, yeah. So find open direction and then toss movement into there. Okay, but anyways, find open direction should do. I like having 2 spaces between them. So it takes in a direction, right? Checks at 90-degree intervals for obstacles. Returns first unobstructed. Returns first unobstructed direction if all obstructed returns vector 90 degrees counterclockwise of input. Okay, there we go. So now we know what it needs to do. Well, now we have documented what it needs to do. And it's pretty clear. So just loop while this current vector hits an obstacle. And then, oh yeah, you literally just need to do this, right? And then, yeah, you can just say if M is the I'm trying to think here. Yeah, I mean, we could just do something as simple as like an account. Just increment the count, and then if the count is equal to, it would be what? You would go, so we start here, it'd be one, two, three. So if the count makes the 3, then give up. Otherwise, just return M. Let's log. Let's do debug log. Direction. And then let's do M1. Would be M plus count plus that plus direction. It might be worthwhile too to debug draw line. Start would be transform dot position M in color dot white for 1 second, and then do that. Okay, I don't actually know if that's gonna do too much. All right, I'm gonna do some thinking here. Might be able to test this. So it goes through these, right? That's not really, it shouldn't be too, that really shouldn't be important. But then, so first of all, we're gonna determine the target. We're gonna set the movement towards a target, whether it's that or that, and then normalize. And then let's just do this movement times equals, actually do RB dot I don't want to be doing get rigid body every single time. RB. No. Private. Rigid body 2D. RB. Then RB dot equals get component rigid body. Yeah, easy as that. Then just do RB dot velocity equals movement times speed. Okay. All right, let's go ahead and test this. Let's also do something real quick. Can we do Control Shift Find? Debug dot draw. Okay. This is in find out direction. That's fine. This is where? Okay. Okay. So now theoretically, if we do this and this, there should be no lines, theoretically, right? No, there is a line. So that's... Why is there a line? I just got rid of all of them. Oi. Why is there a line? Debug.draw. Find all. No, it can stay there. I just wanted to expand it. Okay, so it's right here. Enemy movement. Oh, yeah, that was the part I forgot to do. Yeah, comment out all that. Now, I'm going to go and uncomment these because I'm pretty sure there's nowhere else where there's a line. I knew that there was somebody. Because I was like, I'm pretty sure I saw lines before I was doing any of this. Okay. All right, let's try this again. What time are we at? 6:37. The stream is going by like really fast, but also slow. Okay. So interesting. Interesting. Okay, so where we at here? Okay, so it goes input M1, M2. Input M1, M2, input M1, M2. So that's good. I just feel like it's not drawing the lines in the right place. Oh, it's because it shouldn't be checking M. It should be checking. Wait, yes, it should be. But draw the line to transform position. Plus N. Oh, for Y. Bro, it's just so complicated. I don't know why. Why they gotta make this so hard? I don't know why they just don't like. You can't inherently convert them. I don't think you can, right? Like, unless I'm crazy. I think if you did vector 2 equals vector 3, it works. But I'm not going to do that here. I'm not going to do like this. Blah, blah, blah. Like, it's just... Whatever. Whatever, man. Unity, just do your thing. I don't even care anymore. Alright. Let's see what we got here. Let's see what we got. I think that's fine. And again, it goes like, okay, input is... Input would be like pretty much at 1. And then it's checking -1. So it's like 1, 0. And then it's checking -1, 0. And then it's checking... Oh, yeah, 1. No, yeah, 1, -1, 0. Okay, but this is going back to that, which is interesting. It shouldn't go back to that. Yeah, so all of them are going... comes in, we're getting this input, right? So that's the direction. So we get the direction as the input, and then M1 is perpendicular once. I want to try something. Let's do vector 2a equals new vector 2 1 0, right? And then we're going to debug dot log a, then do a equals vector 2 dot perpendicular a, and then boom boom. So it should go from 1 0, print that, to then it would be 0 1, print that, then negative 1 0, print that, 0 negative 1, print that. Okay, so that's what we want to do. So this is good testing right here. This is good testing. So it's 1 0 0 1 negative 1 0 0 negative 1. Okay, that's what we expected. Now let's do I don't remember what it's called. What is this function called? Find open. Yeah, it is find. I knew it was find. Find open direction. Okay. Save. Oh, forgot to pause it again. Whoops. Okay. So these four, and then it's 1 0 0 1, and it's done. I think that should be fine. I don't think that's gonna be. Darn it! I keep forgetting to pause it. Oh man. Okay. Let's go and just pause that. Clear this. Play this. Okay. Just go and pause it now because I don't need to do anything else. 1 0 0 1 negative 1 0 0 negative 1 1 0 0 1. Then it goes to 1 0. Why? I do not know. I do not know. Okay, so there's definitely something wrong here. No, there's not. I just keep printing direction. That's the problem. That's the problem. And honestly, if you just copy this and did it here, you're going to get like a double count, but it'll at least give you all three of them instead of just two. No, it won't. Oh, well, because it stops there. Yeah, so it goes to 3 sometimes. Does it always go 1, 2, 2, 3? Okay, I guess that's not terrible though, because we're not doing anything to correct it per se. Well, no, it's not even about the corrections. It shouldn't have to go around 3 times. Right? Okay, what if we do this then? What if we do this then? What if I get rid of these other... Interesting. I feel like it's not. Yeah, I mean, we could see like debug that log count. I'm a fish bro. What's up, bro? How you doing? How you doing? Thanks for hopping on the stream. It's pretty slow right now. We're kind of just relaxing. Just doing some debugging, working on some new movement code. But thanks for hopping on, man. If you want to play the game, it's in the description of the video and also in my account bio. If you want me to play it real quick and give you kind of a once through, I can definitely do that. Just let me know. If you want me to walk you through the whole thing. But thanks for jumping on, man. Appreciate it. Hey, thanks for the follow. Thanks for the follow. Appreciate it. Means a lot. Means a lot. All right. So this should return something other than, well, if it returns anything, then that's good, right? Theoretically. Yeah. So I'm doing this all in Unity. So I'm using all C# for this. It's Unity's native language support, I would say. It also supports Java quite well, but I think it's more common to use C# with it, I should say. But yeah, it's all done through C# and Unity. Let me pull up. That's not what I wanted to do. This is all the Unity here. But yeah, so this is all C# and then all the configuration and whatnot is done in the actual Unity engine itself. Okay, let's see if this returns anything good. I think anything is good. If it returns nothing, then that's not good. Let's see. There we go. 1, 2. Okay, so it does return sometimes. Where's the point? If we do this. Interesting. There's no. Okay, so I think it is returning something sometimes. Oh, actually, can we not collapse these? Wait. Maybe I lied. Maybe I do want to collapse them. What are these points that are returning? Enemy movement 181. No, this top one. Okay, just do that. What else is? Because I don't want them to collapse. I want to see them all. I'm a project manager in a software dev company. Used to be a front-end dev. Watching Twitch to feel some kind of flashbacks. Hey, that's good though. That's good though. What kind of front-end dev do you used to do? I work in cybersecurity for an insurance company. Um, more on the infosec side. I work with like password protection and like vault softwares. So that's what I do. But front end encryption is pretty cool. Or front end, not front end encryption. Front end dev is pretty cool. That's pretty neat. I feel like that's pretty sick. And project manager has got to be one of the hardest jobs, bro. Like, there's such like a, I feel like there's such a. It's mostly online. I don't know how prevalent it is in companies because I feel like in my company, there's nothing against the project managers, but I feel like definitely like on social media and online, there's definitely a huge stigma against like project managers. And it's not even because of them. It's mostly because the way that companies are structured and how a lot of companies use project managers, which is unfortunate. But like theoretically, project managers aren't bad, but it's when you start to like over. I mean, in reality, project managers are never bad, you know? Like, it's really just when you start structuring a project so that way it's way too complex, that's when the project becomes bad. And then the project manager gets a bad rep for it. It's not really ever the project manager's fault. I mean, they're really just managing. Like, they're just, I don't know. What's your experience being a project manager? I obviously have no experience. So I'm curious. If you get any of that, if you get like annoyance from devs and you just got to be like, look, it's the way it's got to be done, or if it's not like that too much. Because as I said, like my company, I never have a problem with project managers. I think project managers are chill. They keep me in line. They keep me from like going off and doing random stuff. Pure.js all the time, just simple plugin development, some Vue.js. Vue's cool. I did Vue for my senior capstone project. I did a lot of Vue. Vue's pretty neat. All of those like JavaScript frameworks are pretty crazy. They're just I feel like they abstract what they're actually doing to such a degree where like you really have to stop and understand. Like when you stop and think about what they're actually doing, it's like crazy. My okay, cool. My like off stream side project right now is setting up a lamp stack and just making like a pretty simple web interface, and that's been very interesting. Like I can't just go in with PHP and do like dynamic web page updating. Like I can't just have certain parts of the web page updating. You got to do your classic get post requests, and that's about it. I'll make it complex as I keep going, like more complex as I keep going. But as of right now, I'm just like, it's straight PHP SQL. That's it. That's all I got. Like PHP SQL HTTP or HTML, not HTTPS. HTML, PHP, and SQL. I don't even think I've done any CSS yet. But I'm kind of just like, I'm starting off just like the basics, and then gonna make it more complex as I go. Once it's all functional, I'll probably, start adding the bells and whistles on there. But that's pretty cool, bro. That's pretty cool. My STLC, you open your ID and look for reservation. Wait, what do you mean SDLC? I apologize. I am not familiar with that. Death cycle. Sorry, that definitely should have been common knowledge. Honestly, I kind of just go for it. Like nothing that I'm doing right now is I've really like tabled as a long-term project. Um, like the code in this game right now is so bad. Like it's horrendous. There's so much overlap, like so much redundancy in all of this. Um, this is really bad coding. Like all this is terrible coding. I probably said it so many times throughout all my streams, but it's really not good. I kind of just go for it, and sometimes my thought process is just it's better to get something done than sit out and try and structure the perfect code, because it's a lot harder when you're working on a personal project. I am definitely It's very easy for me to fall into like a perfectionist mindset and to like just go off wildly trying to like make sure everything is the best it can possibly be before I even start. And so with personal projects, a lot of times I really have to limit myself and be like, all right, I just have to do it. Like I'll think about it for a little bit and then I just do it. Like there's 10 different ways I can get it done. And sometimes it's really come back to bite me, and other times I don't really know that it would have mattered either way. But I mean, when I was setting this up, when I like first started this game, I was like, I just need to get everything working. Like I can go back and refactor, I can go back and clean stuff up later. Like I just wanted to get everything in and functional. So, but for the lamp stack, I don't know. I really don't have any like life cycle in mind for it. I just kind of run with it. Yeah. I don't know. That was an area that I don't really have a lot of. I really wanted to get more knowledge on how like coding actually works, because obviously this is one thing in my degree I felt like that was not really taught it wasn't emphasized super well. I'll say I feel like it wasn't emphasized as well as it should have been, but it was like, yeah, just open your IDE and make sure you use abstraction, make sure you guys are like make sure you guys know what your code is, using polymorphism. I'm like, all right, that's cool and all, but like all I know is write this code and I know how the code works, but I don't know how the code actually is doing what it's doing. I don't know how it compiles together. I don't know. And for like web development, I literally knew nothing about web development before I started this project. Like I could maybe tell you the 7 like network layers. Like that was it. So this has been a really nice project to kind of get me more familiar with how all that works at the base. And that's why I didn't want to use something like a JavaScript framework, just because it's so abstracted. So I'd rather kind of, start underneath that and kind of build up. And like, I'm not trying to push something out in a month, 2 months, a week. Like, I don't know. I'll probably work on this for the rest of the year. I'll probably build 1 or 2 websites and just kind of do that. Yeah, exactly. That is pretty much my mindset. Especially with like game like this. Like I'm not building this game to work on to like be a better programmer. I'm definitely learning things as I go across, and I'm learning a lot more about building bigger projects because I don't really work on things that are this big, hardly ever. And so, especially as it expands and I start like going back to stuff, trying to add stuff, I'm like, oh, bro, like this, who built this? Who wrote this code, bro? This is terrible. But I'm not trying to intentionally better my program. That's not the main goal of this. The main goal of this is to make a game that's cool. So if the programming behind it is subpar, oh well. I don't really care. So I mean that's my mindset. I'm just building stuff, kind of going along, trying to build a community here. So if you ever want to come around, my schedule is on my Twitch page, but I stream Monday, Wednesday, 5 to 7 Eastern time. So that being said, I am wrapping up here, unfortunately, but I really appreciate you joining that. I will be back on Wednesday to continue more fixing bugs and trying to figure out Boyd movement. I should say trying to implement Boyd movement. I know how Boyd movement works, but implementing it is the hard part. But yeah, I'll post this. Also, these videos, I post all these VODs on my YouTube channel as well. So if you ever want to watch them in your spare time just to kind of chill or whatever, background noise, go for it. The YouTube link is somewhere on my Twitch page. It should be in the About section on my Twitch page or in the links section. But that being said, I'm going to get out of here. I'm going to go make some dinner. Probably some pasta. I think I have some leftover pasta, so I'm gonna go make that. But have a nice rest of your day, and hopefully I'll catch you another time. See you, man.